Assalamualaikum warahmatullahi wabarakatuh and a good day to the panels and fellow audience. In this video, I would like to present to you on my final year project proposal on the title of the Development of Internet of Things, IoT Fence Interference Detection Monitoring System. The researcher is me myself, Ahmad Kamal.tajuddin bin Kamarulzamil. I'm from the Faculty of Mechanical Engineering and my supervisor is Dr. Zulkifli bin Muhammad. We're going to the project summary. The general idea of this study is to provide an improvisation of the current fence perimeter intrusion detection system (PIDS) into the fence detection interference system by implementing initial measurement unit as a sensor mechanism. Not just that, the study is to create a fence interference detection system with the functionality of monitoring the whole process via a web interface dashboard. Moving on to the introduction. The current implementation of the vibration detection from the PIDS mechanism is mounted on fence, detects and analyzes whether the vibrations indicates an intrusion attack attempt. While the application commonly used on fence of civil and military airports, energy source depot, military bases, nuclear plants, embassies, weapon ammunition libraries, and so on, which are under security threats and need to strengthen their safety precautions. Apart from the initial mechanism, a fence detection interference system concept is a kind of perimeter security system, where this new implementation consists of a control and a peripheral part that has a remote monitoring function which is also intended to protect assets and for those who have best interest in an unauthorized person or animal probing their defense and probably seizing their assets. And lastly, the demand of progressing relation society on the increasing safety and stability in terms of economy, society, features, and infrastructures. Next is literature review. Firstly, PIDS has been in the market of fence-mounted detection system for quite some time. Most fence-mounted detection use a transducer and also an electrical transducer mechanism which acts as a physical instrument that transforms one form of energy into another, such as a frequency and wave. And an electrical transducer transforms various types of energy into an electrical signal. The limitation of PIDS should also be considered when the detection, incident identification, and potential threat from the alarm have the probability of malfunctioning and cannot react appropriately. Next is initial measurement units. In this study, I am using the F-Robot BMX 160 IMU, which is a combination of accelerometer, gyroscope, and a magnetometer sensor which senses motion as well as its types, rate, and directions. The rate of acceleration as well as changes in rotational characteristics such as pitch, roll, and yaw could be measured while monitoring magnetic induction using a combination of such sensors. Next is microcontroller. A microcontroller is a compact integrated circuit that is housed inside each component needed to carry out the required activities and design it to command specific functioning operation in an embedded system. This study can use a range of microcontroller models from multiple providers. Hence, the selection of microcontroller should be considering a few factors including the cost effective if the requirements are met effectively, the robustness and the facility that have wide availability and reliability, and compilation of the selected device which have the availability of the software development tools. The selection of Node MCU ESP32 was made following the advantages of the processor in terms of availability, which is more powerful than ESP8266 by multiple functions, a faster rate of receiving data, and Wi-Fi which you could see from the table provided. Last but not least, the software web dashboard. The development of the software is of utmost importance since it provides means of showing the data obtained from the sensor measurement via a microcontroller to a user interface. There are various ways to integrate the microcontroller output into the desired software as you can see from the table provided. But hosting a web hosting was used as a platform to display the preferred interface. Hosting a web hosting is an online service that can integrate and build content accessible on the internet domain. This web host provides the hosting technology and resources required for the effective and secure operation of the website. It is selected based on the desired infrastructure, price of the platform, and also the developer and user friendly. Moving on to the problem statement. The current IDS has a few limitations in terms of recording precise data measurement to be collected and monitored through the user interface. Not just that, the transaction conversion takes an extra in receiving an input of a signal which is by the transducer and extracting it into signal condition before transform the signal into a desired format. Additionally, it will be a tedious job to convert a signal into an output, where precise measurement data is needed in monitoring system. The next one is the objective of the project. There are three objectives highlighted on this project, which is the first one is to develop a functional fence detection interference monitoring system. Number two is to calibrate the efficiency and precision of the sensor used in the system towards the integration of the software interface. And lastly, to test the performance of the fence detection interference system on site. The development of this fan detection interference monitoring system will be focusing on the application of the sensor by calibrating the measurement of the gyroscope, accelerometer, and magnetometer towards achieving the precise value. Through this study, there is a limitation in gaining the measurement. Hence, the applied calculation will solely based on journal research forces towards the fence and not real circumstance, such as the forces of animal intrusion and the impact of car crash towards the fence. Other than that, the installation of the system will be on a sample built fence prototype. The next one is the methodology. For this part, a set of flowchart has been made in order to develop this fence interference detection monitoring system. It is started with listing all the literature review, including the mechanism, the component of each of the hardware and software development. Then, the design part will be carried out in the procurement mechatronics to find the best component for each of the desired requirement. Next, the integration of the hardware system into the software system to ensure the monitoring mechanism can be carried out. If the system can be validated, the next step is to build and installing the hardware and software component. A select of improvement need to be carried out to ensure the system performance. Lastly, to conclude the progress of the system. The integration for the hardware and software will be continued if the system can be validated. This is the system layout. A set of forces will be applied to the fence after the sensor is mounted to one of them in order to measure the angle, or in this case positioning, acceleration, and magnetic induction. As the data from the sensor was gathered, the parameter were put through a decision-making process. If the necessary parameter wasn't high enough, the mechanism switched back to the force detection. It will be shown on the dashboard of the web interface for the end user. For the IoT layer, as you can see from the figure provided, the function of the system started from the vibration, movement, and location detect from the fence, which can be determined from the force exerted. The data will then transmit and push toward the cloud by using Wi-Fi LoRa long-range spectrum modulation technique from microcontroller ESP before it's saved and managed inside the data lakes of the specific database. Programming from a software front-end web hosting will process the data to enhance the location, system status, or even warning status, and then query it to the user layer, which will be displayed on the web dashboard. In my research planning for next semester, I'll be starting with the first one, designing, programming, and calibrating hardware. The next is designing the web interface dashboard. Thirdly, integration of the hardware and software. Next one is testing and calibration of the product. And last but not least, to gain the result, discussion, and conclusion. For my expected result, I need to manage the integration of the data push into the cloud from the hardware before being queried toward the front-end user interface. Next is to do the testing of the control unit on the built fence prototype to get the precise and calibrated measurement. I will also need to gain initial and end result of the calibrated accelerometer, gyroscope, and magnetometer measurement with precision for the hardware. And lastly, I need to make sure the web dashboard can display the measurement of the calibrated accelerometer, gyroscope, and magnetometer measurement. That is all for me, and thank you for listening. If you have any concern or question, please reach me out through comment section down below or through my email akamal.tajuddin@gmail.com. Thank you and have a nice day.